Yes, end of the last class, I asked about the when H is discontinuous in case of linear and semi-linear PDE.
You have tried that problem?
Yes, sir. I took a particular example and
Yes. You
tried.
just take uy plus ux equal to 0, that example. So what did
Yes,
you
sir.
get?
So I got the solution, but I think that is also discontinuous.
Yes. Okay. We will see. We will come to this problem again. Okay. Okay.
Okay.
We will come to this problem again. Okay. Good. Very good. Okay. So let's start. Let us start with the, as Atharva said, let us start with the previous last example, the propagation of discontinuity, right? You remember the problem we consider, is the following. Uy plus ux equal to 0 when x is in R and y positive, and u at x0 is equal to h of x. H looks like 1 when x equal less than 0 and 0 when x is positive. We can solve the problem as we know how to do that. So finally the characteristic curves looks like characteristic curves are x is equal to y h of s plus, you know how to solve this. I am not doing the solving, just recall the fact what we see last time. Y plus s when s is negative and s when s is positive, because you know that h is 0 when x is positive, so s is positive, is this part is 0, only s left, and this is 1, so y plus s. Now what is the speed of this dx by dy is h of s, yes, which is equal to 1 when s is negative and 0 when s is positive. Okay, so the characteristic looks like this. For s negative, its slope is 1. And for s slope is 0. You know why I am doing this, because I have taken the opposite. So what the conclusion is? The conclusion is the characteristic line intersect the characteristic line intersect for all x positive. Okay, for all x positive the characteristic line. So in this case it is impossible to define. So in this case it is not possible, we know that it is not possible to define a, what is that, to define a classical solution, or is called smooth solution, classical or smooth solution of the PDE for x positive. So this is the conclusion. Since the characteristic, we have already seen that if it's intersect, then there is a discontinuity in the solutions. We have seen all these things. Okay, now the conclusion is that it is not possible to define a classical or a smooth solution of the PDE for x positive. Then what is this? And I said that this is one of the very important example of a PDE which comes from the Burger's equation. These are called the Burger's equations, right? Burger's equation. And there might possible that the initial conditions are not good, like it is just one discontinuity. Then how to study this PDE? That means how to define. We have to introduce a new notion of solution. We need to define a new notion of solution, because this classical or smooth solution does not exist for this problem, right? Then we need to define a new notion of solution. Okay, we will see which is called the solution, which is called the entropy solution, which we will call it's the entropy solution. Of course, this name came from the physics, entropy solution. We will tell you in the next class what is the entropy solutions. Okay, and we will study a bit of this type of problem, and also this is known as the Riemann problem, right? Riemann problem. Okay, clear? Is that clear? The scenario is clear. So since we cannot able to define a classical solution for this PDE, because as you know, X positive, the characters like intersect, that means there is a obvious discontinuity there in the solution, U solution. We have seen all those examples, how it comes. Okay. And since there is no classical solution for X positive, we need to define a new notion of solution, which is called entropy solutions. Okay. We will see in the later class. Okay. Maybe in the next class we will see. Okay. Okay. Now, as far as what we have done study how to solve linear equations. Linear equations we have seen. Then what we did? Then we did the semi-linear equation. And then we did quasi-linear equation. Quasi-linear equations. Okay. So what left? Anyone?
Non-linear.
Fully non-linear. Fully non-linear equations. So today's class we will concentrate only on this fully nonlinear equation. So in practice, I could tell you that fully nonlinear equations are very difficult to study. Okay, of course, for our case, we will just take a simple problem and we'll just have some knowledge on it. But as such, as a research topic, you can say that fully nonlinear equations are very hard to study. Okay. Anyway, so but of course for us this is not a very difficult one. Okay. So let's start with nonlinear equations. So what can anyone tell me what is a nonlinear equation? Huh? Can anyone give an example of a nonlinear equation?
ux square equal to uy square.
Ux square equal to?
Uy
Huh?
square.
Yes, kind of. Yes, this type of. Okay. Now we intend to study. Now we intend to study fully nonlinear equation. Nonlinear equations. Okay, which has the general form, which has the following general form. What is that? F of x, y, u, ux, uy. So it might happen that the equation involving ux and ui has a nonlinearity. Okay, this might have a nonlinearity. This might have a nonlinearity. The highest order derivative might have a nonlinearity. Then we call it's a fully nonlinear equations. Okay. Okay. So any idea? So this is this is some variable. This is some variable. This is some u depend on. This is a z actually. Z equal to u of xy. So ux or uy. So what is the obvious idea to do? Because now ux and uy also has a nonlinearity. So what is an obvious or what is an obvious idea to start with? Can anyone guess? Huh? Because now u and this has also a nonlinearity. So what we should do to study this equation? Can you get some idea? Of course, with the help of characteristic, but can you do something? Can you have some more idea on this? Anyone? What we
Maybe
can
we
do
can
that we
try
can.
to
Uh-huh.
maybe we can try to modify equations so that it turns into some quasi or semi-linear form.
Kind of. Yes, good. Kind of. So we first make ux and uy also a two more variable. Okay. You understand why? Because x is a variable, y is a variable, z is a variable. Z is your ux or u of xy. Because ux and uy, u subscript s and u subscript y also has a nonlinearity. So the obvious way to handle this is also a some two more variables. So you introduce two more variable on the equations. Okay, that means now you have to study. Earlier, what we have to study? Earlier, we have to study three equations, right? Three equations with initial conditions, right? System of equation has a three rows, right? X, Y, Z. Now let's introduce a two new variable ux and uy as well. Okay, then this is an equation of five variable then. Okay, so there should be a five equations ODEs. Of course, when we are doing with a method of characteristic, we convert it to an ODE with the method of characteristics, and we should have a system of ODE will consist of five rows, right? Okay, and therefore we should have also to study this, to solve this ODE, we should also have a five initial conditions. You understand? Okay, so let us set two mode variables. Okay, p equal to ux, q equal to uy. So now our fx, that equation, so we have x, y, z, p, q is equal to 0. Okay, okay. Suppose f has the form this. Suppose f has the form f of a x y z some ux. Of course, I am taking a easier form just to see how this pq will play a role. Okay, sorry, this is pq minus c of x y z. You know what is p and q. P is nothing but p is your ux, q is your uy. Okay, okay. Then can you tell me? So of course you should take your initial curve gamma as same thing. X of st is 0, y at is 0, and z as 0, as usual. Okay, okay. Then can you tell me? Can you tell me what is dx by dt? Huh? What is dx by dt?
AX, YZ.
Exactly. A x y z. Similarly, we have seen this dy by dt is b x y z. Okay, and of course now you tell me, now if I differentiate f with respect to p, what I will get? Anyone? What is df by dp? Huh?
AXY. AF.
Exactly, a x y z. What is df by dq? Because this is
D.
now your independent variables. Huh? What is
D.
df by dq? B of x, y, z. See these two equations. Okay. So what we obtain now? Can you tell me what is pdf? Sorry, p df by dp plus q df by dq. Can anyone tell me what is this? P into a plus q into p, and what is equal to ap
C.
plus qp equal to c.
C.
What is c? Z by. Clear? So we write for this type of form f, we write if p is dx by dt. Okay, dy by dt is fq. dz by dt is pfp plus qfq. But now we have this is also an unknown, fp and fq. So we need to have an equation on for p and q as well, right? Yes or no? Hello?
Yes.
Because you know df by dp, we want to study in terms of p and q also. Okay, so we need equations satisfied by P and Q as well. Okay. So what we will do, what is dP by dt? Can anyone guess? This is ddt of u of x. What is that? ddt of u of x is equal to ddt of ux at xt yt. What is that? What is that? Come on, uxx x prime t plus uyy y prime t.
Sorry, UXY.
Okay.
UXY.
Sorry. uxy y prime t. Okay. So what is this? What is uxx? What is uxx?
E prime.
fp.
dp by
Yes.
dt.
Yes. Clear? fp or not? And what is x
Yes.
prime t? What is x prime t? dx by dt is fp and uxx is
EX.
yes. Clear? Okay. But still we have to find dp. What is fp and fq? Yes. Okay. So differentiate capital F now. But your f of equal to 0. That is, what is f of x, y, z, p, q is equal to 0. Now differentiate all, because you have to be careful with the with respect to x variable. Okay. What I will get? F of x, chain rule. Apply chain rule. Okay. F of x plus f of z into zx plus f of p, px plus f of q, qx equal to 0. So now see, so fp into px plus fq into qx is equal to minus fx minus p into fz. Okay, so this imply, just go behind here, dp by dt is this, fp into px plus fq into qx. So you can substitute fp by into px with fx and fz. Okay, this imply dp by dt, because dp by dt is this, now you substitute this value instead of this. So dp by dt is minus fx minus p fz. Okay, similarly you can compute dq by dt is nothing but minus fy minus q into fz. Clear? So now we have 5 equations. Now we have 5 equations. What are those? Can anyone tell me? What are those? What are those? What are those?
dx by dt equal to fp.
dx by dt equal to fp. Yes. Then dy
dy
by
by
dt equal to fq. dz by dt equal to pfp plus qfq. dp by dt is equal to minus fx minus pfz, and dq by dt is equal to minus fy minus. What I just one thing I have used is the chain rule. Okay. Okay. Now just system will not. So ODE theory says that we need to have a x of s0 is fs. We already know this. F of s. Yes. Y at s0 we already know this. We write as g of s, and z of s, of course we know that this is z of s plus is h of s. So the question is, what is p of SC. And what is Q of SC? Unless we prescribe these two initial value, we will not able to solve this system of PDE, sorry, ODE. Agreed? All of you agreed? Unless I give these two initial value, we will not be able to say that this system of ODE has a unique, locally it has a unique exist locally, the solution exists uniquely. Okay, for that we need to prescribe the initial condition on the variable P and Q. Can anyone tell me what should be that? How to get these initial conditions? Anyone, any idea?
So the initial conditions must also satisfy the PDE. So
Very good, very good, very good. So first of all, that is one part. The initial P naught, let's say this is called P naught. This is, let's say, P naught. This is, let's say, Q naught. Okay. So P naught and Q naught should satisfy satisfies the PDE. Very good. That is F of all initial conditions should satisfy the PDE. GS, HS, that we know already. P naught of S, Q naught of S. That is equal to C2. This is one equation we got. So you have to find P naught and Q naught. Okay. So you know F, G, and H. So this is one equation P naught involving P naught and Q naught. So other is we need two equations to solve P naught Q naught, right? So given F, G, and H, you can compute P naught. So P naught Q naught satisfies this. This is one equation. Another one is, just look at it. Z of S0 is equal to HS. So what is Z of S0? U of Fs comma Gs, that is equal to H of S. Now you derive this function. H of S is Ux F prime at S plus Uy G prime at S. This is all at time t equal to 0, at time t equal to 0. So this is Ux, this is your P at time t equal to 0. That means this is P naught into F prime of S plus Q naught into G prime of S. So this is another equation. H prime of S is P naught F prime of S plus Q naught G prime of S. Because your F, G, and H are given. So these are the two equations and two unknowns, P and Q naught. P naught and Q naught are the unknowns. So there are two equations and then P naught and Q naught are unknown. So you can, two independent equations. So you can easily, P naught and Q naught is solvable. So P naught, Q naught is solvable from this star, let's say star, and let's say star star. Is uniquely solvable. Okay. This is solvable. So you obtain P naught and Q naught from these two equations. Okay. Now you can write down what is P naught. What is P naught and Q naught are nothing but which satisfies these two equations. Clear? So now you have a system of 5 ODE with a initial condition. And suppose of F, G, H, P naught, Q naught are all smooth or a C1 function, these imply existence and uniqueness of such ODE. Existence plus uniqueness locally. Yes. Existence and uniqueness locally. Okay, Picard's via Picard's theorem. Via Picard's theorem. Is that clear? Is that clear to all of you? Huh? Let us, please tell me. I will wait for 3-4 minutes to tell me. Is that clear to all of you? How to tackle the, of course I will give now example, but at least is it clear up until now? Yes or no?
yes.
Let's start with it. Example. Let us begin with an example. With an example. What is the example? Ux, uy equal to u. X comma y is in R. U not y is equal to y square. Okay? U of x into u of y equal. This is a nonlinear. Is it a nonlinear equation? Yes or no?
Yes, sir.
Yes.
Nonlinear equation. Nonlinear equations. Very good. Because the coefficient has the highest order. Okay. Now you tell me. What is f of x, y, u, p, q? Huh? What is that?
PQ minus Z.
Excellent. PQ minus Z. Clear? Because your p is, you know, ux, q is your uy, x less than and z equal to u of xy. Okay. So f of x. Excellent. Now you take the initial parameterized space curve. Consider initial parameterized space curve. Okay. Is gamma is what should be the parameterized space curve? Anyone? Anyone? Quickly.
0 t square.
0 s square. Okay. Very nice. So your fs is 0, your gs is s, and your hs is s. Okay. Yes. Now what is the first equation? P naught Q naught satisfied? P naught, you remember? P naught, just go through it. What is your P naught into F prime S plus Q naught into G prime S equal to H prime S. So P naught into, what is P naught into F prime S plus Q naught into G prime S is equal to H prime S. So what is H prime of S? So H prime of S is, what is?
2s.
G prime of S is 1 and F prime of S is 0. You substitute here. So this imply P naught into 0 plus Q naught into 1 equal to 2s. And these imply Q naught equal to 2s. That is S equal to Q naught by 2. Yes or no? Is it clear or not?
Yes.
Oh. Now how to find Q naught? You know that f of x, y, z, sorry, f of x at the time at the point s x as st, s at 0, fs, gs, hs, p naught s, q naught s, that has to be equal to 0. What is this? What is f? So p naught into q naught minus h of s is equal to 0. So P naught into Q naught is equal to s square. And what is Q naught? You know what is Q naught. What is Q naught? P naught is into Q naught. Q naught is 2s. 2s equal to, if s not equal to 0, if s not equal to 0, this imply P naught equal to s by 2. Clear? So we have found all this. So your Fs is 0, Gs is S, Hs of S is S square, P naught of S is S by 2, and Q naught of S is 2S. Clear? We all got the initial conditions. Now how to what is dx by dt? Can anyone tell me what is dx by dt equal to fp? Huh? What is fp? What is fp?
Q.
Q. Because your f is actually nothing but pq minus z. So del f by del p is nothing but q, because x, y, z, p, q are all independent variable. So q. What is dy by dt is equal to fq. And what is fq? Del f by del q is p. That is p. Okay. And what is dz by dt? Dz by dt is pfp plus qfq. That is equal to pq plus qp, that is pq is equal to 2pq. That is equal to 2pq equal to, what is that? 2pq equal to, what is that?
2Z.
Very good. 2pq equal to 2z. Yes, 2pq equal to 2z. Now what is dp by dt? dp by dt is minus fx minus fz into p. Fx is 0, so this is, and fz is 1, so q. Sorry, this is p, so minus p. What is dq by dt? Anyone? Q. If you just compute, dq by dt is fy minus fz into q, it will get q. Okay, because minus z is there, so q. Okay. So you have 1, 2, 3, 4, 5 equations.
Sir, fz equal to minus 1. Fz is equal to minus 1 minus plus.
What?
P.
I cannot hear you. I cannot hear you. Tell me
dp by
again.
dt is equal to plus p.
dt by?
dp by dt is equal to plus p.
Plus p?
Yes, sir.
Okay. Okay, no problem. So dp by dt equal to plus p. And dq by dt equal to minus, na? There should be one minus. No. Both plus, right? Both plus. Okay, good.
So sir, it is minus dp by dt.
dp by dt equal to minus, you just see. dp by dt equal to minus fx, this is 0, minus fz. Fz is minus, this is plus 1 into p. It's plus, right? Am I making any mistake? Yes?
No, sir.
Yes, sir.
Is it okay?
Yes, sir.
Okay. Anyway.
Okay, sir.
So dp by dt equal to p, dq by dt equal to q. So what you can say here? dp by dt equal to p. So p is equal to? P is equal to?
E to the power t.
S in. Huh? What?
S by 2.
Huh? P at S. Agreed? Agreed or not? Because you will get P at ST is something, a constant, depend on the a constant S naught into e to the power t. Now you just apply P at S naught, P at t equal to 0. This is S naught equal to S by 2. So, okay. Similarly, you get Q at ST is 2s e to the power t, I guess, if I'm not wrong. Just a minute. Yes, right, because you have to 2s. Okay. So this is Q. Okay. And what is Z of ST? Z of ST you will get s squared e to the power twice t. Okay. So also dx by dt is 2s e to the power t. This implies x equal to 2s e to the power t minus 2s. dy by dt is nothing but p, that is equal to half s e to the power t plus s by 2, I guess. If you now, yes, can I, yes, please, yes, please. I cannot hear you anything. Please, I cannot hear you. Hello, hello, hello. Someone is telling something. Please, hello, hello. Anyway, so if you change all those things, you will get x by 2 plus 2y is 2s e to the power t. You will get, so if you do this by 2 x by 4 plus y whole square, you will get s square e to the power 2t, which is equal to z. And this implies z equal to x by 4 plus y whole square. This is the solution. Clear? Is that clear? Just have a look what I have did. If you want, I can repeat again. Is that clear?
Yes.
All of you others?
Yes, sir.
Clear? Is it clear? Okay. Okay. Now this is an example, and finally we will do something which is not that interesting, but we have to do this because it is in the sub syllabus. This is something called complete integral and singular solutions. Okay. Complete integral, and something called singular solutions. Okay. You want to find all possible solutions of a PDE. Try to find. Of course, not always it's possible. We'll try to find all possible. This is just I showed one example, one way to solve this PDE, right? So I give one solution. So it might happen that it might have other solutions also. So complete integral and a singular kind solutions. First of all, what is the meaning of those definitions? First, we have to define what is meant by a complete integral and what is meant by a singular solutions. Okay. So now let us fix a set A in R2. Be an open set. And set. Okay. Let A is ordered pair A1, A2. And of course, capital X is X comma Y. Okay. Okay. Let I define a symbol D of A. A means A1, A2. U comma D2 of XA. This is the matrix. This UA1, UA2, UXA1, UYA1. This is UXA2, UYA2. Yes, so this is the matrix. Just define. So you are given a set A where small a is A1 and A2. It belongs to the set A. Okay, X is any point in R2. X and Y, the ordered pair. So I define a set. This is just a set. This is the notation. This is the matrix. This. Okay, 2 by 3 matrix. Okay, okay, okay. Now we say definition. A C2 function U subscript say X, okay, is said to be to be a complete integral in, you can say this is at u at xa, okay, in omega cross a, because this is a function of x and omega is an open set in R2 and a is also an open set in R2 of the equation f of x y u ux uy equal to 0. Okay, if u is said to be a complete integral of the equation this, if u x sum a solves one, pointwise sense solves one, and the rank of, this is very important, rank of dau comma d2xau is 2. That matrix has a rank 2. This matrix has a rank 2, huh? And you can tell me why the problem is, because this A hanging around is because the initial condition is not prescribed. Okay, so this is just a PDE is given. We haven't prescribed the initial conditions. Okay, so you would like to find the family of solutions of this PDE. Okay, we want to try to find all possible solutions of this PDE with, and also this PDE has not given any initial conditions. Okay, that is why this A is hanging around. This, depending on this A, we will find a solution of this PDE. This will be very clear once we go to the example. Okay, you understand the point? You understand? So u is said to be an complete integral of the equation this, if u x, you can say subscript a for a is in open set, u x a solves this equation, and this matrix, this 2 by 3 matrix has a rank 2. Is it clear? Not really, right? Because you can say that what this a is. So for any a also, this will satisfy these equations. Okay, depending on a also, whatever a you take in an open set A, these will solve these equations. Okay, somehow the idea is, somehow you would like to consider all family of solutions without knowing the initial conditions. Clear? Is that clear?
Why rank 2 only?
Because
Why consider?
why rank 2? Because it's a 2 by 3 matrix, and if the rank is less, there is something called singular solutions. We will come to that. Okay, that is why we call as complete integrals and a singular solutions. Okay, yes, is that clear? So there should not be any degeneracy in the solution. Okay, clear? That is why we need rank has to be 2. Okay, clear?
Yes.
We will see. Okay, example. Find the complete integral of the following. Same. Okay, what is f? This is your p q minus z. So the characteristics are, you see, there is no initial thing. Characteristic equations are dx by dt equal to, you know, fp, that is q, dy by dt is fq, that is p, dz you can compute, dz by dt equal to 2z, you already did, dp by dt is equal to, you can check, this is p, and we have done dq by dt equal to q. The problem is now we cannot have a initial condition, so we have to have a parameter solution. Okay, that means P equal to C1 e to the power t, Q equal to some constant C2 e to the power t, Z is equal to C1 C2 e to the power 2t plus C3. Okay, and X is equal to X you can put because X is Q. X is actually Q means C2 e to the power t into t, that is C2 e to the power t plus b. Yes or no? So am I making some mistake? No, it's okay. C2 e to the power t plus b, and y is equal to C1 e to the power t plus a. Okay, and all C1, C2, C3, C3, A, B all are unknown because this is a parameterized one. Okay, so these imply C2, you can say C2 e to the power t is equal to x minus b, right? So we want to simplify this. C1 e to the power t is equal to y minus a. So now multiply these two equations. C1 C2 e to the power 2t is equal to x minus b, x minus b y minus a. And what is C1 C2 this one? Can anyone guess what is this? You see here. This is z minus c3 is equal to, because this if you substitute z minus c3 equal to x minus b y minus a, and these imply z of x y, you can say a b is something x minus b y minus a plus c3. Clear? Yes or no? Clear or not?
Yes.
Your this a is nothing but a comma b, you say a bar. Okay, your x is nothing but x comma y. Now you have a solution. X comma a bar is nothing but, what is the solution? X minus b y minus a plus c3. Now can you guess what is c3? Can anyone tell me what is c3? We know that this will solve the equation ux into uy equal to u. This imply ux into uy, if you do, if z satisfy ux into uy equal to u, then that is x minus b into y minus a, that is equal to x minus b into y minus a plus c3. Just zx comma a bar satisfy this equation. If you substitute zx zy is equal to z, then you will have end up with this equation. These imply C3 is, provided these are non-zero. Okay, provided these are non-zero, C3 equal to 0. So we have a solution z x comma a bar is having x minus b and y minus a, which I can write it as like this, that xy plus ab minus a comma b dot x comma y, which I can write as xy plus ab minus a vector, this a bar vector, comma x vector. Okay, this is that R2 inner product. Okay, clear? So this is the solution. So I say that, so this z of, you can say zx satisfies the equation. Now we have to check that it has a rank 2, right? What is dau comma d2, sorry, a bar x a bar u? This is nothing but b minus x 1 0, that is a minus y 0 1. What is this rank? So the rank of this is equal to 2. Is that clear? So these imply that z x a bar is equal to x minus b into y minus a is a singular solution. Sorry, is a complete integral. Complete integral. Clear or not? This much as at least it is completely follows from the definition. Everything, is it clear or not?
Yes.
Or others? For others?
Yes, sir.
Clear? May I go forward? Okay. Now there is a twist. Instead of this type of substitution that I did here, that I made it like this, we can do some other substitution also. Can we get a separate solution? Let's see. Just with the same problem. What we have? P is C1 e to the power t. Q is C2 e to the power t. So these imply P by Q is C1 by C2. You take that to be some A. Okay? Okay. And also we know PQ equal to Z. So you just substitute here P equal to AQ. P equal to AQ means AQ square equal to Z. And these imply Q is equal to plus minus root over Z by A. Of course, assume Z, A are all positive. Okay. Assume. Otherwise, we can't do this. Okay. So for A positive. Positive. Okay, good. Now what is P? P is nothing. You can substitute Q equal to P by A. If you do that, you will get P equal to plus minus root over AZ. Okay. Now we know that also that dz by dt is equal to P dx by dt plus Q dy by dt. So this is plus minus root AZ dz plus minus root over Z by A dy by dt. Okay, if you do this Z here, that is dz by root Z. Root Z is equal to plus minus root A dx by dt plus minus 1 by root A dy by dt. Now integrate. Integrate. We left with integrate, we get, by integrating we get 2 root Z is equal to plus minus root over AX plus Y root A plus some integrating constant C3. Agreed? All of you agreed? It's nothing. This is just a calculation. You just integrate now. So you will end up with respect to t, you end up with this. Okay. Now you can say that Z is equal to some C3 square by 4, I think you will get, plus 1 by 4 root AX. Yeah, you don't now square it and you do it carefully, that you have root Z is plus with C3, root Z with minus, you take Z root Z minus 1 minus this one into root Z plus this one, that is C3 square you will get. You can know how to do this. I don't have to say this. Root A. This imply Z is equal to some B plus 1 by 4 root AX plus Y root A. Okay, so this is your B, this is your A. So you have a solution X A, that is A bar, which is B plus 1 by 4 root AX plus Y root A. For A positive, of course we start with A positive because here only we can say A positive. Okay, so you can check easily the matrix. Now you can calculate the matrix A bar D2XA U Z. Sorry, that is U. If you calculate, you have a rank. The rank of this matrix 2. If you just compute, okay, square. This is square. Sorry, B plus 1 by 4 root A plus root square. Okay, so rank is 2. So for A positive, we have another singular, another complete integral. Another complete integral. Another complete integral, which is given by Z x A vector is B plus 4 root AX plus X by, Y by root A whole square. So this is one complete integral. Another complete integral we have computed is, this is X minus B, Y minus A. This is another. Of course, this holds for any for all A, B in R, but this holds for only for A positive. Okay. So for A positive, we have another solution, right? Agreed? Both are the complete integral, you can say. So, can you tell me, am I missing some more integral? Some other solution are we missing? Are these are the all solutions of that PDE? Just can you tell me that we are missing something? One more solution you can get immediately. These are the two family of solutions. Equation is ux, uy equal to u. What is the other solution? Which are not covered by this and this.
Zero solution.
Exactly. Zero. From here you cannot never will, because A is positive, will never get zero, right? Am I right? Yes or no?
Yes.
And also you see this cannot be zero because we argued like that. That C3 is zero by arguing that this is non-zero, right? That is x not equal to A, y not equal to, sorry, x not equal to B, y not equal to A. Okay. So all AB with x not equal to B and y not equal to A. So both this, U is a, of course, trivially U is a solution which is not covered by these two solutions. Are you agree? Is it correct? You agreed? With these two solutions, zero is not covered. You agreed or not? All of you. All of you. What happened? You agreed or not?
Yes.
Yes, sir.
Yes, sir.
Okay. So that means this complete integral are missing some other solution. In case we are lucky that U is a zero, we can see immediately. But this complete integral will not is not giving all the possible solutions, right? We are missing something more. That means we need to say something, need to define one more type of solutions. Okay. So the remark is, in the previous example, both the complete integral, both the complete integral will give us U equal to 0 solution. This means there might be other solution as well, which is not captured by the previous method. Okay, that leads us to study a new kind of solution known as singular solutions. Okay, this is it. Quite interesting. Not much. You can do it very fast. Okay. Let me define first, then I state a small theorem, and then we give a simple example. Okay. Suppose Ux, your A1, A2, that is your AB, be a C1 function on omega cross A, where omega is an open set, subset of R2, of course, and also A is an open subset of R2. So this is the equation. This is the function. Okay, you know what is that? That is x, y, a, b. That is your x a bar, that function. Okay, if the equations del u by del ai x, y, a1 comma a2 is equal to 0 for x and y in omega, and a is in a is in a, and for I equal to 1 comma 2, if the equation, now new equation, del u by del ai equal to 0, this equation can be solved, if this equation can be solved for the parameter, a, which is equal to a1 comma a2, and has a solution, and has a solution like this: a1 is equal to phi of xy and a2 is equal to psi of xy. That is del u by del ai at the point xy, comma phi at xy, comma psi at xy equal to 0. Okay, then we call the function, this function Vx as u of xy, phi of xy, psi of xy. This Vx function we call the envelope of functions, is called the envelope of functions. You fixed a belongs to a. This gives you an envelope of functions. Okay, so Vx is, so it's clear, right? The statement, the definition is clear. This a1 a2 is your given parameter, be a C1 function on omega cross A, where omega is an open subset of R2, A is also an open subset of R2. If this equation del u by del A1 A2 is with respect to AI for A1 and A2, both these two equations has a solution, which is given by A1 is given by some function of phi xy, the A2 is given by psi xy, that is del u by del I at the point phi xy and psi xy solves this equation. Then this function, the new function defined as u of xy phi xy, is called the envelope of functions. Okay, now the theorem says that, suppose for each a1 comma a2 belongs to A, for each suppose for each a u which is a function of xy, a1 comma a2 solves f of x, y, u, ux, uy equal to 0. So for each a1 in the open set, that you have seen the example, solve this PDE. Assume further that the envelope, the envelope be defined by, what is how it is defined, v of xy is u of xy, p of xy, psi of xy, with this defined by Atto, and of course it satisfies that the equation exists and a C1 function exists and a C1 function, then we also solves f of x, y, u, ux, uy equal to 0, and this v is called the singular solution. Is it clear? We will give an example. Okay. Suppose for each a1, a2, u at the point x, y, a2, this is a fixed parameter. It solves this PDE. Further assume that V is an envelope. That means V solves. That means what is phi and psi x? This is an a1 dou u by dou ai at the point phi x and psi x equal to 0. That, and this is the envelope is a C1 function, and we also solve these equations. Can anyone tell me how to prove this? It's a very straightforward one line. What is V of xy? U of xy, P of xy, she of xy. Yes. What is del V by del x? This is ux at the point x, y, phi, she plus u with respect to a1. This is your a1. This is your a2. At the point, of course, x, y, phi, she into phi with respect to x. Phi with respect to x plus u at a2 x, y, phi, she now with respect to phi of x. Clear? And what is del? Just chain rule. Del v by del y is nothing but uy x, y, phi, she plus u a1 x, y, phi, she phi y plus u a2 x, y, phi, she phi y. What is del? This is, can anyone tell me what is del u by del a1 at the point phi and psi? Huh? Because V is an envelope. So this solves this equation, right? Del u by del y at the point phi xy and psi xy equal to 0. So what is this value? 0. This is also 0. Similarly, this is 0 and this is 0. So this is actually ux. So your Vx is ux and Vy is uy. So it solves the equation. So nothing. So hence for each x belongs to omega, f of x, y, u, ux, uy is equal to f of x, y, u is u, x, y, phi, she, comma, ux of this point, uy of this point, that is equal to 0. This solves the PDE. Is it clear? Hello?
Yes, sir. It's clear.
It is nothing. This is a chain rule. What I can tell here, there is no concept here. This is just a chain rule. This is no analysis. Just you take the derivative and this is nothing. This is just a calculations. What I can tell more on it. Anyway, so I don't know why the students are not coming. Are they not following? Yash, Kritika, Atharva, Vishwa, Nirmal. What happened to your friends? Are they are not following? Is there any problem? Huh? What happened?
I think today most of the things are introduced new things.
Huh? What happened? Please tell me.
Most of the new things are introduced today in today's class. So maybe.
Yeah, these are not that difficult. This is just a computation. But if you want me to again explain, I can explain again. I think this is just a computations. This is just only one concept, chain rule. You have to, so daily, if this equation has a solution at the point this at a1 equal to phi xy and a2 equal to psi xy, then we define a function vx, which is called the envelope. What more I can explain here? Okay, let's do one example and then stop. Okay, if you have some problem, please, we can discuss in the next class. Anyway, maybe you can solve this problem. find all the solutions. Find all solutions. Find all solutions. That means singular plus complete integral. Huh? We'll do that. We'll do that, or I will explain this. We'll do that. Yes or no? Okay, let me do this. If what is f of, for this equation, what is f of u z? Let's say pq. What is that? P square plus q square minus 1 minus 2z. The characteristic equations are the characteristic equations are dx by dt equal to 2p, dy by dt equal to 2q, dp by dt is equal to 2p, dq by dt equal to 2p. Solving this, again p by q is equal to a, and p square plus q square is minus 1 minus 2z equal to 0. You can take this imply, you can take here the equation, you will get p equal to plus minus 1 plus 2 root z, 2z plus 1 plus a square, and you will get q equal to plus minus a square root of 1 plus 2z, 1 plus a square. Yes, same thing. Okay, now dz by dt is p dx by dt plus q dy by dt. You know what is p? It is plus minus root over 1 plus 2z by 1 plus a square. You can change a dx by dt plus dy by dt. Okay? And these imply dz by root over 1 plus 2z is equal to plus minus a dx by dt plus dy by dt. Now integrate with respect to t. dz by dt. Yeah, it is all okay. Okay, if you integrate with respect to in respect 1 plus 2z, you will end up with ax plus y by 1 plus a square plus b. Again, if you solve this equation, you will get that u of x y a b is nothing but half ax plus y by 1 plus s square plus b whole square minus half. You will get this. Okay? Correct? So you can prove that for AB in R, this is a, if A is equal to 0, then you will get, yeah, for any AB, this is a complete integral. It's the complete integral. Of course, you have to check the rank of that matrix. You can check that. Please check the rank. Check the rank. Okay? The complete integral. But how to get the singular integral? Okay? What you have to do? Del u by del a equal to del u by del b equal to 0 you have to make. If you make this 0, this imply ax plus y plus 1 plus a square plus b has to be 0. If you, these two equation will give you this. Okay, that means the singular solution is, so the singular solution is u of x y a b is minus half. This is the singular solution. Singular solution. Clear? This is nothing. What I can explain here. You have to just compute and du by dou u by dou a equal to dou u by dou b equal to 0. You have to solve this equation. You get Vx, and if you can, Vx is this. You will solve this equation. It will be 0. This is the 0. If these two equation will give you this 0, that means u of Vx Vy, this part has to be 0. That means u equal to minus half. And this gives you the single. Okay, we will see this. If you don't understand much for means we'll see later this. There is some geometric way I can explain you. Maybe we can do it later if time permits. I can explain this in a more geometric way. These envelopes and all those things. Okay, if time permits, I will do. Otherwise, you just think as an analytic way to solve this PDE without having those. This is nothing but we are somehow collecting all possible, classifying all possible solutions of a PDE. Okay, this is the main idea, main theme of this part, the singular and complete integrals. Okay. Okay. I think that is that clear, all of you?
Can we put the envelope of integral?
Yes, yes, yes. Huh?
Envelope of complete integral.
Yes, yes. Tell me again, Yash.
I'm saying, can we also make the envelope of complete integral like that we have done?
No, actually, these two are the distinct solutions. You understand? These two are the distinct. Yes. That's complete integral and the singular. That is the way. Somehow we are. Somehow you have to classify all family. We are to see all possible solutions. In some way to the PDE. You understand? Okay. So if you don't understand, you don't have to bother much about this. Okay. Okay. This is there is some geometric meaning, but it's very difficult to explain you with this knowledge. But I will try to see if time permits. I can have one class on this on a more geometric meaning. We'll see if time permits. Okay. This is just the technique. You can see this is just a way to classify all family of solutions. That's it. Okay. Is it clear? Okay. So as usual, tomorrow there will be a tutorial class taken by the tutors. Okay. Please ask if you have any doubts to them. Okay. Next class I will finish this first order PDE. So next class is Saturday. Is the Saturday timetable works like Monday? Huh?
The next Saturday. What
this Saturday is the Monday's timetable?
No, sir. Next Saturday.
Okay, so next Saturday. Okay, okay, okay. I understand. Okay, I understand. Okay, good. Then we will meet on Thursday, right? Next Thursday. Monday is a holiday.
Yes, sir. Yes.
Then we will meet as Thursday. So please have a look because next class I will finish the first order, and this will be the syllabus for you. I will tell you, not now. I will tell you the syllabus for the first quiz. Okay. So next class, please bring all your doubts. Okay. Please bring all of your doubts for the first order PDE. You have a time of 1 week. Please please go through all my 6 lectures. Okay. And bring as much as possible here because next class there is something not much. So 1 hour I can finish the content and half hour and rest of the time I will devote to your doubts. Is that clear? Is that clear?
Yes, sir. Yes, sir.
Please come bring all of your doubts and all those things of these 6 lectures. Okay. Okay. Thank you.